Okay, so now let's consider the integral equation with u naught in H1. Okay, and the non-linearity alpha will satisfy, well, alpha will be between 1 and n plus 2 over n minus 2. F n is greater than 2, and alpha will be between 1 and infinity if n is equal 1 or 2. Okay, so if alpha satisfies this, then for all u naught in H1 exists t. This is a t that depends on norm of u naught, um, 1, 2, okay, and lambda alpha positive, and the unique solution u of the integral equation in the time interval minus dt, okay, with um, u in z minus dt h1 rn intersection lr minus dt, okay, L1 rho, and now we will see what rho is. Okay, so let's put it like this: rho comma r will be, well, rho will be n multiplied by alpha plus 1 n plus alpha minus 1, okay, and r will be for alpha plus 1 n minus 2 multiplied by alpha minus 1. Okay, this is for n greater or equal than 3. In the case where n is equal to 1 or 2, then L1 rho will be defined as, well, as we defined LPS before. This was 1 minus Laplacian minus s over 2 LP Rn. S is in R, okay, and well, we had that the norm SP was 1 minus delta S over 2 F P. Okay, and so moreover, for all t prime less than t exists a neighborhood W of u naught in H1 Rn, okay, such that the function f that goes from W to C, well, the set that we defined with t prime on H1 Rn intersection so like this and like this, Lr minus dt L rho 1 Rn. Okay, this function that assigns u to its solution, u naught to its solution, is Lipschitz, just like we did in the case of the local theory in L2. Okay, so once again we will define the E1TA set of the B's in the, well, the set where the solution is going to be CH1 intersection LRLP1, and such that the B's have this norm, the supremum of B. Now B is going to be in the form 1, 2. And now the integral is going to have this term of the gradient respect to x. Okay, less than equal than a, all the same as we used before. So notice that rho r, this pair, is an admissible pair if we see in the corollary of the local theory in L2, when we say that this in LR rho, L rho is satisfying these conditions for the different dimensions. Okay, so now let's see, if we have absolute value of u to the alpha minus 1 gradient of u norm rho prime, this will be less than equal, we can use Euler here, considering 1 over rho prime equals 1 over, let's say, L plus 1 over rho, and we will obtain a constant multiplied by the norm u alpha minus 1 L, and then gradient of u rho, okay, and this will be less than equal, okay, then z u, okay, always the same that we do, that we when we take out the exponent and obtain alpha minus 1, but then we have to add here alpha minus 1 L, okay, again multiply by u rho. Okay, so now we will use the Solev inequality so that we can bound f with the s, or the derivatives, and then we can use the norm of s comma, in this case was 2. We can use a more generalized theorem where we can use other numbers in this place. Okay, so in this place we will have to bound this with the derivatives, the gradient, and we will obtain that this is less than equal than a constant c multiplied by gradient u alpha rho. Okay, so we will have that this, okay, alpha minus 1 u rho prime is less than equal than c u alpha, but now we will use the norm, this alpha should be outside, 1 rho, okay, with rho prime and rho and the L's satisfying this condition. Okay, as we have this, then we can say that 1 over L is equal to 1 minus 2 rho, and 1 over alpha minus 1 L is equal to 1 over rho minus 1 over n, or that 1 over L is equal to alpha minus 1 over rho minus alpha minus 1 over n. So then we've got that alpha plus 1 over rho is equal to n plus alpha minus 1 over n. We'll have this in mind, okay? So, as we did in all the cases, we'll try to bound phi of u t, okay? So this will be less than equal than c u naught 1 comma 2 plus, and now we will bound the integral c 0 t, okay, u alpha minus 1 u r prime 1 comma rho prime dd 1 over r prime, okay. So this will be less than equal than c u naught 1 comma 2 plus, okay, we will make what we made always in ut, and now we take the alpha out, alpha r prime 1 comma rho dt 1 over r prime, okay, and now we will bound this. We have the same here, u naught 1 comma 2 plus, and now we take out a constant, well, not a constant, but the time t, exponent delta, and 0 t ut, okay, is u, r 1 comma rho, and now we will take the alpha outside, alpha over r, okay, with well, delta will be 1 minus alpha plus 1 over r. This will be equal to 1 minus n minus 2 alpha minus 1 all over 4. So if we take a equal to 2c u naught 1 comma 2, okay, we will get that phi u norm t is less than equal than c u naught 1 comma 2 plus ct delta, okay, u t alpha. This will be less than equal than a over 2 plus ct delta a alpha over 2c alpha, and this as an appropriate use of a, we will have this is less than equal than a. And we will say that if t is sufficiently small, then we get that ct delta over 2c alpha, okay, this all alpha, a alpha minus 1 less than equal to 1 half, and then we will have that t is less than equal, let's put it like this, as in constant, a 1 minus alpha del over delta, okay. So to complete the proof of the existence and uniqueness, it is enough to show that the operator of phi is a contraction, and it's made the same way as we did before with the case of L2, okay.